We've been doing inequalities in one variable, and now we're going to look at how we can graph inequalities in two variables. So the solution set of an inequality that involves two variables is graphed by graphing a related linear equation that forms a boundary of a half plane. So just to see what they're talking about, this looks a lot like when we just graph a line right here, but a line is an equation. We're doing inequalities, and I'll explain why this side is this side is shaded very soon. But that'll be the difference, is that with these, we'll not only have a line, we'll also have one side of the line, depending on what the inequality is, shaded. So the graph of the ordered pairs that make up the solution set, which that's an enormously infinite size, because that doesn't just mean whole numbers. So they don't just mean -2, 0, -2, 1, -2, 2. They also mean -2.1, 0.1, -2.21, 0.01, and everything you can imagine. So it's an infinite number of ordered pairs that make up the solution. So if we're trying to graph y is less than or equal to -3x minus 2, we start by treating it just like an equation. So you see how they take the inequality sign out and change it to an equal sign. And then we graph -3x minus 2. So if you remember, when it's in this form, that slope-intercept form, we can just start by using the y-intercept, which is -2, and plot that point. So they did that right here. And you don't have to draw these, I'm just showing how they graphed it originally. And then the slope is -3, so you can either go down 3 over 1 or up 3, 1, 2, 3, and to the left 1, which is right there. So then you draw the line through those 2 points. Now, since y is less than or equal to this, it's the same as saying both y is less than -3x minus 2 and y is equal to -3x minus 2. The boundary is included in the solution set, so the graph should be drawn as a solid line. So the translation is, if there's an or equals to, you draw it as a solid line. Because since it's or equals to, that means the line itself is part of the solution. If it's just less than or just greater than, you'll draw a dotted line. So that's written here in the steps also. You draw the line, you make it solid if the inequality is greater than or equal to or less than or equal to, and you make it dotted. In other words, just do it like this. If it's just greater than or less than. Okay, the next step is to pick a point, or if you have to, you can pick more than one point to test and figure out if that's where we'll shade it or not. Now you can just do one. As long as you pick a point that's not on the line, one should be enough to choose. And if possible, choose 0, 0. It's the easiest one to do. So we just plug that point, 0, 0, into the inequality. So we plug in 0 for x and 0 for y. -3 times 0 is 0. 0 minus 2 is -2. So I want to make sure you understand, we're testing this point right here, the origin, 0, 0, to see if it would be a true statement in this inequality. But when we plug this in, the result says 0 is less than or equal to -2. That's false. That's not true. So we would not shade in this side of the line. Instead, we'll shade in that side of the line. Because since 0, 0 isn't part of the answer, it must be that the other side of the line is part of the answer. And you can see, this could be why in the example they're doing two. They're picking one on the false side, one on the true side. So we look at the point -2, right here. You can plug this in to the inequality. -3 times -2 is 6. 6 minus 2 is 4. And it is true that -2 is less than or equal to 4. So since it's a true statement, you would shade that whole side where -2, 2 is. On that side of the line is where you would shade it. So let's try following those same steps through these examples. Okay, so step 1, draw the line. Remember, we treat this as an equation first. And y equals 4, when you just have y equals a number, that's a horizontal line. And it's a horizontal line at 4. So 1, 2, 3, 4. So we know it's going to be here. Since there's no or equal to, we need to draw this as a dotted line. So just remember, if it's a solid line if it's greater than or equal to, or less than or equal to. It's a dotted line if it's greater than or less than. Since this one's less than, we do a dotted line. That shows that the line itself is not part of the answer. It's a boundary for the answer, but it's not part of the answer itself. Okay, so again, I would just pick 0, 0 anytime I can. The only time you can't pick 0, 0 is that the line actually crosses the origin at 0, 0. Then you've got to pick something different. I think we'll see that on number 3. Okay, so I'm just going to pick 0, 0. Well, there is no x to plug in 0 to, but we can plug in 0 for y, so we get 0 is less than 4. That's a true statement. So we can shade this part in. Which makes sense. If y is less than 4, it makes sense we go below 4. This one says x is greater than or equal to 1. So remember, we will graph x equals 1. Just like y equals a number is a horizontal line, x equals a number is a vertical line. And I did draw a solid line. Thankfully, that was the correct thing to do. It's correct because we have an or equal to, greater than or equal to 1. So I'm going to pick the ordered pair 0, 0 again. I plug in 0 for x. I'm plugging in the inequality. 0 is greater than or equal to 1. That is false. So I do not shade on this side where the origin is, because that's a false statement. 0 is not greater than 1. So instead, we shade on the other side of the line. Okay, on number 3, they write it as 3x is less than or equal to y. Nothing wrong with that, but we're used to having y on the left side. So just like we've done before, you can flip it around the other direction. So it's the same thing as writing y is greater than or equal to 3x. Our slope is 3, because that's the number in front of x, the coefficient. And there is no b, or I should say it doesn't appear, because that would mean we have a plus 0 understood there. So the y-intercept is 0. So we do start on the origin, and the slope tells us to go up 3, 1, 2, 3, over 1. And since this has an or equal to sign, I will make this a solid line. And this is one where I cannot use 0, 0. Now you can use any point you want that's not actually on the line. Like I said, I tend to use 0, 0 when possible just because it's so easy to compute when you plug in 0, 0. So I'll just plug in the point 1, 1. So I'm going to pick 1, 1 as my test point. And you can plug it in either version, whichever you want, this one or this one. I'll do this one since that's what used to help us graph. I plug in 1 for x, and I plug in 1 for y. So 1 is greater than or equal to 3. That is false. Okay, so 1, 1 is right here, and we just found out that doesn't work. It's false. So we have to go on this side to shade it. Okay, number 4, we'll follow the same process. We have a slope of -1/2. We have a y-intercept of -3. So we go down for our y-intercept down to 1, 2, -3. So I'll draw a dot there. And it says I need to go down 1 and over 2. You can also go up 1 and to the left 2. You can see they follow the same line pattern here. And since it's just less than, there's no equal to, I have to draw a dotted line through here. And again, I would pick the point 0, 0. That's fine because it's not on the line. So we plug in 0 for x and 0 for y. Half times 0 is 0. Minus 3 is negative 3. So that ends up being 0 is less than negative 3. It is not true that 0 is less than negative 3. So this is the false side over here. We do not shade it. Instead, we shade the side that's opposite. Okay, number 5, the easiest way to do this, in my opinion, is to go ahead and solve it for y. So I'll write that work up here. 4x minus 3y is less than 6. Subtract 4x from both sides. And then we need to divide everything by negative 3. So first of all, because I divided by a negative number, I have to reverse the inequality sign to say greater than. Negative 4 divided by negative 3, I'll just call it a positive 4/3, because negative divided by negative is a positive, so 4/3 x. And then 6 divided by negative 3 is negative 2. So make sure when you do this, you do divide every single term by whatever's in front of y. So we have a slope of 4/3 and a y-intercept of negative 2. So I'll start at the y-intercept, negative 2, and the slope is telling me to go up 4, 1, 2, 3, 4, over 3, 1, 2, 3. Since this is just a greater than sign, we will have to do a dotted line. And then we'll need to plug in a point. So I'm going to plug in 0, 0. I'll plug in 0 for x. Plug in 0 for y. 4/3 times 0 is 0. 0 minus 2 is negative 2. This is saying 0 is greater than negative 2. That's true, so I do shade in the side that has the origin on it. So true statement, you do shade that side. False statement, shade in the other side. Okay, I'm going to skip number 6. I think you've got the idea by now. Now on the back, we see us going the opposite direction. So on the front, we are given equations and asked to graph them. On the back, it's going to give us the graph and ask us the equation. So first, we need to find the equation of the boundary. And the easiest thing to do there is start with the y-intercept, in this case negative 2, and then figure out the next spot actually hits a point. So let's see, it hits the point 1, 0 right there. So we have the point 0, negative 2, and the point 1, 0. If you want to do the slope formula like they show here, feel free. You can also just do rise over run. You see it goes up 2 and over 1, meaning the slope is 2. So they just used that information to write y equals 2x minus 2. Now the boundary is dashed, so we know we'll use either less than or greater than. And just like we use 0, 0 often before, we use 0, 0 again. So we know it's either that y is less than 2x minus 2 or that y is greater than 2x minus 2. Now feel free to pause and check their work, but the short of it is when you plug 0, 0 in this one, it gives you a false statement, so that can't be right. Because we see it is shaded, so 0, 0 has to be a true statement. When we plug it in the greater than version, it is true, so that tells us this is our equation. So let's follow that same pattern down here. So right here, we start by finding the y-intercept. It's a positive 1. And it's generally easier to find the slope when you move from the left to the right. I know we found this point first. We're doing the slope. It tends to be easier to start with the point on the left. So on this one, we're going up 1 and over 2, meaning the slope is 1/2. So our equation is y equals 1/2 x plus 1. I just got that from finding the slope and the y-intercept. Now, since this is a solid line, that means we either have to use greater than or equal to 1/2 x plus 1, or less than or equal to 1/2 x plus 1. We know it's got to be an or equal to because it's a solid line. So now we can pick 0, 0 again. We know 0, 0 should be true. So if I plug in 0 here, I get 0 is greater than or equal to 1. That's false. So that can't be the right one. Plug in 0, 0 here. We get 0 is less than or equal to 1. That's true. So our correct equation is y is less than or equal to 1/2 x plus 1. Okay, I'm going to very quickly go through number 8, and then we'll close. So this one, we see the y-intercept's actually way up here at 1, 2, 3, 4. So the y-intercept is 4. Our slope is 1, because you can see these 2 points marked. It goes up 1 over 1. So we get y equals 1x, or you can just say x, plus 4. Now we want 0, 0 to turn out false. And since it's a dotted line, we know it's either less than x plus 4 or greater than x plus 4. So when I plug 0, 0 in here, I get 0 is less than 4. That's true, but we don't want 0, 0 to be true because they didn't shade in the side of 0, 0. Sorry, let me back up. It turns out 0 is less than 4. No, I said that right. Sorry. I'm confusing myself. 0 is less than 4 is true, but we're not looking for one where 0, 0 is true because it's not shaded. 0 greater than 4 is false, so that means that aligns with the equation they gave us, or the inequality they gave us. So y is greater than x plus 4 is our answer.